Alright, I'm working on a 1994 Yamaha Virago. I believe it's an XV535, and just doing a whole bunch of work to it for a buddy of mine. And I figured while we were here, I would put on a set of, I don't know if I'm blocking the microphone or not, a set of LED turn signals for my friend. We kind of did away with the old bulbous and crazy looking ones, and we got these pretty nifty looking LEDs and wired them in. Everything seemed to be okay, and noticed that when I turned on the turn signal switch, this happened. You can see it. It's a pretty cool little light show we got going on here. And the relay is just going bananas. So, also that they're both flashing, so I don't know, that's another issue, but I guess I'll handle it as I go. So, what I wanted to do next is I wanted to get an idea of circuit design. So the next thing I did was I got a wiring diagram, and I got this guy off the internet, off of somebody that actually had the service manual. And simply enough, what I did was I started at the flasher relay, and I went from the flasher relay up back to our left hand handlebar switch, and I saw that I got a brown with a white tracer. On this diagram, the tracer is kind of indicated by these little dots along the wire. And we also have a yellow with a red tracer. So those are pretty much the only two that are connecting my flasher relay to my left-hand handlebar switch. So the next thing I did was pulled out my second or third wife. I don't know if you want to call it that or the other, but some say it's overkill, but I love this thing. And I scope the hell out of everything. So set it to DC volts, and I figured I would check the yellow with a red trace. I did splice these guys because I know what's wrong, but I really wanted to go back over it because I feel it's got some value to it. So I went ahead to the yellow with a red tracer, and what do we got so far? We got 1478. Oh boy, that's the old faithful, the old Charger over there. It's one of my faves. I love that thing. So anyway, before we what I'm going to do is just kind of hit the button. I'm going to hold it in the on position, and it goes right to 0, or damn near close. So when I hold it, it's pulling it down. I let it go, shoots back up to battery voltage. You know what, let me shut this charger off. That would be kind of a good idea at this point. So there it is. So I don't know if it's relevant. I think it just might be a sense for a safety switch or something to that effect, but I don't believe it has much to do with our circuit. So I'm going to move on to the next wire, which is a brown with a white. If we take a look actually at the diagram, we can kind of see how they're interconnected in the switch, which is really cool how they kind of do this for you. If we look at the yellow with the red, we can see it goes across to ground, which is basically what we're seeing when it's depressed. So more than likely it's to help break the circuit when you push the button in to turn the turn signals off. That's just me guessing, but anyway, I'm not really too worried about that. I'm going to go on to the brown with the white now. Alright, back to the tool. Come on. And you can see we got a ton of noise. We're flashing, we're clicking, and we can definitely see all that insanity. We're going to go on to the other side now. So each side makes that hash occur. And looking at the lights, I can definitely say, without a question of a doubt, that that is my flasher relay output. And basically it kind of sums up what I kind of have going on in my head here. So this is basically a 2-pin relay that's inside this box. And what happens is voltage is live all the time. Let's go to it right now. Right now the switch is off, and that's its output that's coming out to the switch. So we got 12 volts coming out of the flasher relay going up to the switch, and the flasher relay is essentially closed right now. And when you hit the button to turn on the switch, the circuit is closed up here at the handlebar, and the flasher relay has a basically an element inside that heats up and opens, cools off, closes, making the bulb flash on and off. And what makes it do that is something called electromotive force, and it's due to the current being drawn by the incandescent light bulbs on the motorcycle. Due to the fact that we don't have that kind of current being drawn because of the LEDs, there's not enough electromotive force to keep these contacts closed for any given period of time. That's why we're getting the buzzing and flashing. This is a pretty common problem on bikes, especially when guys change their signals out. And I didn't really find a whole lot of information out online, and a buddy of mine was doing the exact same thing, and he was really struggling, and I wanted to see if there's a way I can help. So this is my way of helping. So what I did was then I went out and I got one of these. Where is it? It's in my pocket. This is a pretty cool little relay. I've used them a bunch of times already. There's the part number. It's good for up to 150 watts, which is like retarded for LEDs. You're not going to need this much, but I buy this thing all the time anyway. And basically what we're going to do is it's going to go in place of the relay that's internal to this relay box. It's going to go in place of the flasher relay that's internal to this box. We know that this wire here is our output, so we're going to connect the output side of this, which is the black wire, to the wire that goes up to my handlebar, and then we're going to connect the red wire to a known good power source. That is it, pure and simple. So I'm going to hook this in, and we're going to see what it looks like.